All right, am I live? Am I live? I think I'm live. Sweet, all right. Well, I am back. I am back, everybody. I am back. I'm alive. It's been a while since the last stream, I know, but I got a little busy. But I'm back. Good to be back. Alright, I'm gonna set this timer real quick. 30-minute stream. Cool, alright. Well, so, it's been a bit. Definitely been a bit since I streamed. Yeah. Kind of a little bit of stuff got done, actually, between the last stream and this one. I took some time off to learn a little bit of pandas. Also did a little bit more hacking with pandas, and as you can see, I've got Jupyter open right here, so I got a Jupyter notebook going too. Nothing too crazy, pretty simple stuff. But yeah, kind of refactored a lot of code, and thought it would be a good time to start streaming again. So maybe first thing to just kind of show off is what's changed. So before I really had all of my data was kind of loosely being loaded from a bunch of JSON files. So I've since implemented some code that will actually take all that data and compress it all into single file, single table, tabular databases. So for example, this right here is a table of all the data from all of these JSON files. And this is just a small working set, just to show off the concept, because the full data sets are enormous. I mean, there's thousands and thousands of files, and the total file size for the final database is pretty large. And this is only for the month of March, actually. And then I also have it for, I think, all the data I've had so far collected. It's over a gigabyte worth of data for multiple months. But yeah, so now I've got this data in a table, and now that it's in a table, I can work with the pandas library to do all the data crunching and manipulation and plotting and fun stuff. So from here, what happened is I just did kind of a fun little exercise that I'm going to continue to work off of today, which is basically, I'll just run this, I'll rep this, and I've also started working in Jupyter, which is really nice. Makes things a lot easier to kind of test stuff out in a more incremental and modular way. Right, so this is just the dependencies. So let's load this data set. So I've been working with this data set from March. This is all the data from the month of March for this network. Let's run this. So we'll load the data set. This step takes the longest. Doesn't take too long, just a few seconds. But this will read all of that data from that CSV file, that table, into this all data underscore df pandas data frame object. So that contains all of our data. And just as a test, right, I can print out some things. So here I'm printing out the index, right? That's sort of the x dimension of the data. Right now it's just unlabeled, just the index of the row number. Then I have this, which is just a little bit of pre-processing that I do. I wanted to convert all of the times to the pandas or really the Python's datetime format. And then I also wanted to calculate this capacity ratio, right, which is the ratio of so each entry in this table. Maybe I can even show that here. You can print what each entry in the table is actually showing. All I have to do is print that variable, right? And you could see it's showing basically the number of bikes and docks available at a certain point in time, wherever this last reported timestamp is. So what it doesn't have right now, so right now it has, all these reports versus some point in time. But what it doesn't have is it doesn't have the ratio of the number of empty bikes, or the number of bikes to the total possible number of bikes at that station, which I call the capacity ratio. So I have to compute that, and what I'm doing here is I'm just adding that as that value as a new column in this data set. It's really easy to do with pandas. Right, I'm just taking the number of bikes available divided by the capacity for each timestamp. And then the next step, I am grouping, so this step, right, what I want to do with this script that I'm playing with is I'm basically trying to look at statistics for each station ID, or each station, right? So this data is not unique by station, it's unique by timestamp, right? Like the data is being reported as, for this given time, for some station, here's all the information about that station. And then at a different point in time for a different station, possibly a different station, could be the same station, here's all the data again at that time, right? But what I want to do is I want to collect all of the data for a single station or per station and then calculate statistics, right? So that's what this group by function lets me do. It's really the pandas version of what's the function in SQL. There's a similar function in SQL that does this, but it's like an aggregator function, right? So this group by function tells the data set to collect all of the entries sorted by station ID. So that becomes your new x-axis. And then I can apply some functions to it to calculate, apply a function to all that data. So this is saying group all the entries by their station ID, by their station, and then calculate the mean, the average value for each column in that for that station, for each station, right? So this is calculating the average of capacity, of longitude, of whatever you can think of, even name, which is kind of funny because it's a string, but it'll calculate the mean for it. And then, of course, the standard deviation as well. And then so I just save those calculations to, these new variables here. Data average by ID, data standard deviation by ID. And now that I have this data, what I can do is I can plot it. But what I wanted to plot here is actually something kind of interesting. So I'm going to make this a figure, actually. To make a figure with matplotlib, this little bit of code right there. Cool. So I'm going to run this. All right, cool. And so you can see this is showing, right, the how can I make this window bigger? I don't know. I do not know. Both the average and the standard deviation across all of the entries that I have in this data set, right, versus time. I've taken the average of all of those and the standard deviation of all of those for the capacity, should be capacity ratio. Run that again. Oh, nice. The zoom fixed itself for each station in this system. So you can see there's over 500 stations, probably like 550 or something like that. And for each of these, I can see the average capacity for the month of March and the standard deviation for the capacity over the month of March. So pretty cool. Good start. But what I really want to do is I want to start mapping out this data geographically, right? And so I'm just kind of doing a very simple way of doing this, which is all this data set includes the longitude and the latitude. I don't know if it's going to show latitude here. It's not. Longitude and latitude. Oh, there it is. Of each of these entries, right? So each of these stations. So by doing this, by having that data, I know exactly where geographically each station is located, right? So here I'm actually plotting the data from here, right? The average capacity, just the average actually, versus position in latitude and longitude for each station, right? And this kind of makes like a really simple map of this data. And so here it is. And this is actually, okay, let me go back a little bit, because I actually decided to zoom into a specific area. So I gave the map some boundaries here, but I did not have to do this. In fact, let me see if I can, what's an easy way to get around this? I am just going to go ahead, oops, just going to go ahead and kind of fake this. I don't actually know where the boundaries of, say, Boston are, but I'm just going to make these values like really big. So this would be the top left corner of the area that I'm looking at. I'm just going to make this something like that. And this is the bottom right corner. This should be X and Y, so this should be a larger value, this should be a smaller value, and Y, and this will be a larger value and a smaller value. Okay. Let's run this, see what I get. Oh shoot, it's going to plot all the bounds. But that's because I did change the limits as well. Let's just comment that out. Alright, cool, there we go. These are all the bikes in the station, in the system, plotting by color, where the color represents the average capacity for that station in the month of March, right? So the colors that are warmer are more full, average capacity was higher, and then the cooler colors represent stations where the capacity was lower. And if you're wondering why there's kind of like this big cluster here and then that little island there, well, this is all of Boston, Cambridge, Somerville, right? This is the main city. And then that's Salem, actually, which is about half an hour north of the city. They've installed Boo Bikes there as well. So that's why there's kind of this little like satellite island over there. And so the cool thing about this data, I mean, already, right, we have kind of a colorful map showing all these different stations. And what's really kind of interesting is, you know, there are actually a significant number of stations that are that have been mostly empty during that whole month of March, and then a lot that have been kind of mostly full during that month. And I would say, well, one caveat in this data is kind of that that March was a pretty cold month. It was a pretty rainy month. I think it was rainier than average. So, you know, we didn't have as much bicycling activity as maybe you would in a warmer month. But still, right, you could see that, yeah, there are a lot of stations that, you know, were sitting in sort of this healthy mid-range of you know, what I would assume would be, you know, stations that are getting a good amount of use. Maybe these stations down here are not getting that much use, or they're getting a lot of use and they're just in so much demand that they're always empty. But these are the kind of things that we can look into. Now that we have our data, we can chart out a story about this data. So yeah, and then what I did, I just wanted to be able to zoom in into certain areas, right? So I picked some boundaries for the longitude and the latitude to some rectangular area, and we can plot that as well, just to see kind of what the stations in this particular area look like. Yeah. So that's how you can get more spatial granularity. But what I also wanted was more temporal granularity, right? Because this is counting the average for every single day and every single hour and minute of the day. And we know that capacities will fluctuate a lot within a day. So this next part was looking at getting the same data, but by hour as well. So the first thing that we had to do is just add hour as a new column to the data set, to the original data set, because it wasn't in there before. And that's really easy to get because it's already a property of this date time object. So now we have hour of the day. And then what I wanted to do was I wanted to get the average and standard deviation of the capacity ratio by station ID and by hour as well. So now we're grouping by two different fields. And again, Pandas makes this really easy to do. You just use something called a hierarchical group by, right? So what this does, I mean, it's really simple. You just have to pick two different columns to group by, and then Pandas will create groups based on rows with the same station ID and the same hour of the day, right? So we'll just run that. So this line calculates the, that line gives you the grouping, and then this line calculates the mean and the standard deviation for each group. And now we can actually plot by hour of the day, right? So again, we're looking at, well, let me run this. It's the full station. Yeah, so this is the full system again, right? But now we're looking at the statistics for just noontime, right? So this is just the data during noontime, and this is what the capacity, the average capacity looked like. Then we can easily change this, like say we want to look at 7 a.m. That's what it looks like there. Already you notice maybe there's a bit more red, there's a bit more full stations in the morning. Look at 8 o'clock. We can see how things change, right? 9. And actually this isn't really, the color here isn't really plotted the best way because it's being renormalized every single time it plot. But we can fix that by setting the boundaries of the color, or the vertical axis, to always be between 0 and 1. Alright, so let's do this again. Alright, there we go. 7 o'clock, 8 o'clock, 9 o'clock. Yeah. You can see that, it doesn't look like the station's really changing, or the data's really changing that much. Oh, that's interesting. The data from Salem dropped off. I must not have any data at 10 o'clock for Salem. Alright, here you can see something has kind of changed, right? It looks like more of the stations are becoming cooler colors, right? So that means that some stations are starting to empty out. Noontime. Oh yeah, now a lot of red has become green and blue. 1 o'clock. Let's go up to 5 o'clock, 5 p.m. See if things start filling up again. Yeah, not too much change. But again, we're looking at such a large granularity, right? We're looking at every single station in the data, in this data set. So it's not that easy to tell what's really going on. We're kind of still seeing like a bird's eye view averaging of all these colors. But like before, we can look at a specific neighborhood. And so that's what this little snippet of code is doing. So here is just my neighborhood. We can extend this a little bit. Let's extend this a little bit. Show some more stations here. And then let's start looking at, I'm going to add the hour back in here. Look in the morning again. And in the morning we could see, oh, there's a few pockets of red, some green as well. Most of the stations are filled. We can skip ahead to say 10 a.m. Oh, now we're seeing some of those dark reds are becoming, more orange, so there's less spikes available. Look at noon. Now a lot of the stations are becoming much cooler colors, so they're a lot emptier. Now at noontime, say 2 in the afternoon, looks pretty similar to noontime, right? Let's look at 5 o'clock, or 6 o'clock actually. Still pretty empty, right? But this should be when people are starting to return home, so let's look at 8 o'clock. Still empty. Oh, that's interesting. 10 o'clock? People are just out and about, enjoying their nights. 10 o'clock, wow, yeah, still not really full at all. I have no data at midnight. Let's look at 11 o'clock. Ah, right, if I want midnight, this should be 0 o'clock. There we go. Yeah, pretty interesting stuff. Wouldn't really expect the capacity to be changing in the sort of the early hours. Yeah, so that's what I got so far. I just wanted to do a quick thing today, which was to change the way that these plots are shown, which is right now they're just kind of these dots floating in space. But I'd like to instead plot this as sort of 3D columns. So I want to make it look like a skyscraper plot. I don't know how to do that, but I'm gonna just go ahead and look it up. So matplotlib, and hopefully we can do this. Let's say 3D bar plots. That's what I want. Demo of 3D bar charts. Let's see if this is what I'm looking for. Yeah, something like this. Something like this. I want some space in between, but let's see if this will help me do it. Bar 3D. X, Y, bottom, width, depth, top, shade, true, shade, false. Interesting. Okay. Let's try this out. Right, so right now I'm using the scatter 3D function, but I want to change this to bar 3D. Right, so I'll do X. I don't need this. And so my X data is longitude. My Y data. Start a new line. Latitude. Bottom. I think it should be 0. Yeah. I'm going to guess top is the Z data. So I'll put that there. Now for width and depth. this seems like the kind of thing to play around with. So let's give this some value. Let's say, I don't know, let's make it 1. Depth equals 1. We'll just play around with this. I'm not sure what depth does either. Let's see, is there some documentation? Bottom, width. Okay. Let's look this up. Parameters required. Here's the documentation. Huh? Bar 3D. There it is. XYZ, DX, DY, DZ. Huh. Is that different than what I'm showing here? It is, actually. Okay, what is DZ? Scalars. Color. Oh. Let's give this a go. So X, Y, Z. Z. I can tell what dx and dy are. I'm not sure what dz is supposed to mean. Right. Let's say width, depth, dx, dy. No idea what dz should be. Let's just give it a 0 for now. Color equals none. Color equals none. Color can be a single color value. Array of color of n, length n bars. Array of color length 6. Let's leave it as none and see what happens. Color equals none. Oop. Or true. Alright, I'm gonna give this a go. Feeling it might not really do what I want. Whoa. That is funky. Wow. Weird. Okay, I'm gonna need to see more examples. Let's see. It's also really old. Really old. I have a feeling I should be using this one. This looks a bit more, this looks updated. What's 3D box surface plot? I don't think that's what I want. Okay. Let's look at okay, what is the rest of this code doing? That's a plot, projection 3D, fake data, X, Y, X, X, Y, Y, X, Y, okay. Top is X plus Y, bottom is 0, width and depth are both given a value of 1. Okay. Let's give this one a go again. I'm not sure which one's more updated. I think this one's more updated. Now, it looked like from here that all of the well, top and bottom looks like they have to be the same size. But let's see what happens if I just make bottom 0, 1 scalar, width, depth, and then top will be the Z. And it didn't have color as an input, instead it had shade, and they had to be true. So let's have it be true. See how that looks. And I want to change the projection. That's alright. Oh, wow. Weird. Yeah. Let's change the width and the depth. So basically I just want to make it so these blocks don't like overlap with each other. And so we could just kind of go by spacing on this grid. That looks like 0.2. That's another 0.2. So let's make this say 0.1, 0.1. Oh, still really funky. Maybe even smaller. Oh, no, that's actually 0.02 spacing. That's why. Oh, uh-oh. That's my timer. That's all the time I got for tonight, but I do want to keep playing with this. This is really interesting. I think I could get this. It's almost there. It's almost there. Let's make this a little bit smaller. Divide this in half. Let's say. Oh, there we go. It's getting there. They're not square, but that's alright. It's kind of funny. Oh, right. I'm still plotting the still plotting that. And I don't want to do top-down view either. Alright. Wow, I just want to keep playing around with this. This is so funny. Cool. Can I change? Can I set the vertical axis this way? Nope. Didn't like that. I don't think it has that option. Poly 3D collection has no property V-man. Yep. Alright. It's worth a shot. Okay. Well, I'm going to stop it here. I might play around with this a little bit more offline, but yeah. I think I got to where I wanted to be with this kind of this funky little skyscraper view for this data. And yeah. Actually, we could start. So I wanted to plot this way because I think it's a much more. Oh, what is happening? X1 is not defined. X1 is not defined. Cool. Yeah, I think this is much more legible, I guess, way of representing this data, rather than those kind of dots that I was using before. Alright, I'm going to play around this, but I'm also going to stop the stream. So yeah, thanks for anyone who's watching. Catch you next time.